Factors affecting rate of reaction. We have already seen that in a chemical reaction, reactants are converted into products. How quickly these conversions happen is the rate of reaction. Rate of reactions are very important, especially in industries, to obtain the products rapidly and as cheaply as possible. Hence, it is necessary to make reactions go faster, that is, to increase their rates of reactions. 4 major factors affect the rate of reaction. Temperature. Heating is the most common method of making reactions faster. As we've seen earlier, when reactant molecules react, they have to collide with each other with sufficient energies for the reaction to take place. At lower temperature, the number of collisions is lower because particles are moving slower when a collision occurs. Heating the mixture increases the number of collisions and the kinetic energy of the molecules. This increases the rate of reaction. Consider a reaction between calcium carbonate and dilute hydrochloric acid. When calcium carbonate is added to dilute hydrochloric acid, the evolution of carbon dioxide is very slow, as the number of successful collisions is low. Now, heat hydrochloric acid and then add calcium carbonate powder. The evolution of carbon dioxide gas is very rapid. This is because particles of acid have more kinetic energy, and the number of collisions is also more. Hence, temperature increases the rate of a reaction. Concentration of the reactants. Consider the reaction between marble chips, that is, calcium carbonate and hydrochloric acid, forming calcium chloride, water, and carbon dioxide. Take a few marble chips in 2 separate test tubes marked A and B. Add dilute hydrochloric acid to a test tube marked A and concentrated hydrochloric acid in another. Observe the release of carbon dioxide in the form of bubbles. Reaction in test tube B is more rapid. This is because the number of collisions is more in concentrated acid than in dilute acid. Hence, concentration is another factor to increase the rate of reactions. Surface area or particle size. The rate of reaction can be increased by using powder or smaller particles of reactants than using large lumps of solid. Take some marble chips, that is calcium carbonate, in one test tube, and a powder of calcium carbonate obtained by grinding the marble chips in the other. Now, add dilute hydrochloric acid to both the tubes. Release of carbon dioxide is more in a test tube with powdered calcium carbonate. This is because the reaction between hydrogen ions of the acid and carbonate ions of marble takes place at the surface of the chips. Since the reaction takes place at the surface, the chance of hydrogen ions attacking the carbonate ions increases with the increase in the total surface area. This increases the rate of reaction. Consider a piece of marble of 2 cm by 2 cm by 2 cm in dimensions. Its total surface area is 24 square centimeters. If this cube is cut into 8 smaller pieces, then its total surface area becomes 48 square centimeters. And if we further cut it into 64 smaller pieces, then the total surface area increases to 96 square centimeters. Catalyst. A catalyst is a substance which changes the rate of chemical reaction without undergoing any overall chemical change itself. How do catalysts work? A catalyst increases the rate of chemical reaction by lowering the activation energy, providing a surface on which reactant molecules stick temporarily. For example, the use of vanadium pentoxide as a catalyst in the manufacture of sulfuric acid by contact process. In this process, vanadium pentoxide is used for the conversion of sulfur dioxide to sulfur trioxide. The reaction takes place on the surface of vanadium pentoxide. Reactant molecules, sulfur dioxide and oxygen, stick to the surface and orient themselves for efficient collisions. This increases the production of sulfur trioxide. Vanadium pentoxide decreases the activation energy. Initially, only those molecules of sulfur dioxide and oxygen which have sufficient energy react and get converted to sulfur trioxide. The presence of vanadium pentoxide makes even those molecules with lower energy react. Thus, more number of molecules changes into sulfur trioxide. Hence, a catalyst increases the rate of reaction by providing a different route for the reaction. To conclude, we have seen the various factors such as temperature, concentration, surface area, and catalysts affecting the rate of reaction.